Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hi, friends. It is good to be here with you today. I always love Wednesday nights with you. And like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And it is my pride and joy to be here with you, just supporting you through this process of trying to pass that certification exam, because Lord knows those exams are not easy. And that's why we do what we do. We do what we do because we care so deeply about you and you passing these certification exams so that you can be a teacher. So I am Amy Sink. I am from Central Florida, and I have been in education for about 14 years. And a little bit about me, I have a husband and a 2-year-old son and a Great Dane who is like 160 pounds. So that is a little bit about our family. Before we get started, we are here every Wednesday, so welcome. Before we get started, I always like to do a get to know you question. So, and I like to get to know a little bit more about you and what test you're prepping for, because it helps us guide the conversation. So hear me out. These questions are pre-done. Like I made them up, or I pulled them from a resource or something. But these questions are pre-done because I can't just think of 10 questions off the top of my head. But that said, if there is something that you want to see in the upcoming weeks, please let me know. I always have a next week kind of constant ticker running, and I include that kind of stuff in the upcoming weeks. So like someone requested word problems, just word problems in general. We have word problems. Someone requested like teaching strategy, teaching pedagogy, and that's actually what we're going to start with today. And so when you request stuff, it shows up on Wednesday nights. So let me know what you want to see in the upcoming weeks. It helps guide our conversation, and it helps me help you more. So, and that's the goal, really. So in the comment box, let me know where you're from, What test are you prepping for? And what's going to be the fun question? It just makes it feel less like a screen and more like you and I are just sitting in my living room doing math. So where are you from? What test are you prepping for? And what was your favorite field day game as a kid? I don't know why that question popped up, but I remember doing field day as a kid. And I remember like there was always like the water games, and there was always like you just had a blast getting messy and dirty with your friends outside. And in 5th grade, I don't know why I remember this. I remember them slobbing Vaseline on our noses, and we had to run and bend down and pick up as many cotton balls on our noses as we could, and then run back and like shake them off into the pan, and whatever team got the most cotton balls won. I don't know if that was my favorite, but it was definitely the most memorable. So I don't know. That's my field game for you. Hello, you are in Alabama. You're trying to get your Florida certifications and transfer them to Alabama. That's an interesting path. And you need help with algebra. Awesome. What test are you taking? Because algebra in K6 is very different than algebra in middle school. So what are you taking specifically? That'll help. All right, enough about me, a little bit about you. I'll be monitoring the comment box. K6. Awesome. I'll be monitoring the comment box, but let's go ahead and get started. And like I said, we are going to start backwards today. So you'll see question numbers, but we're going to start with question 7 because that's the student pedagogy content side. And a lot of the tests have shifted to that. And then we'll come back to like solving math problems. So we're going to start with problem 7. Which of the following best illustrates the use of individual student math assessment data to guide instructional decisions and differentiate instruction? A, providing all students with the same supplementary worksheets regardless of their performance on the assessment. B, assigning additional homework to students who scored below the class average without considering their specific areas of weakness. C, tailoring small group instruction based on each student's assessment results to target areas of misconception or difficulty. Or D, continuing with the planned lesson without addressing individual student needs identified through assessment data. Y'all, this is a wordy question. So let's go ahead and chat about this. So the first thing that I'm thinking of is I'm thinking of individual student math assessment, right? So which of the following best illustrates the use of student math assessment data to guide instructional decisions and differentiate instruction? So we've got like 3 main components happening here. The use of math assessment data to guide instructional decisions, and not just guide them, but differentiate instruction. Well, in order to be able to reason through this, we kind of have to understand what that is. So math assessment data can be formative or summative. Guide instructional decisions, just help make instructional decisions that's best for the student rather than making instructional decisions that align with a calendar that I created that I have to stay on. And differentiate instruction, tailor instruction for student needs. So let's read through the answer choices. Providing all students with the same supplementary worksheets regardless of their performance on the assessment. Assigning additional homework to students who scored below the class average without considering their specific areas of weakness. Tailoring small group instruction based on each student's assessment results to target areas of misconception or difficulty. Continuing with the planned lesson without addressing individual student needs identified through assessment data. Now, this question is worded a little easier than some of the questions you're going to see on your test. And I recognize that because 3 of the answer choices say, I'm going to do blah, 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 regardless of blank. I'm going to do blah, 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 without considering blank. I'm going to do blah, 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 without addressing blank. So that kind of gives it away that it's C. But those are excellent ways to kind of key in to, hey, that's probably not the best answer choice. So we really haven't talked about math pedagogy. At this point, we've only talked about strategies. And I noticed someone on our Facebook page earlier this week commented and said, like, hey, the STO strategy that Dr. A talks about in his boot camps really don't apply to math problems. And you're absolutely right. They don't apply to problems like this or like this where I have to solve it, but it absolutely applies to problems like this because this is all words. This is all comprehension. This is all like answering a question that is not math related, really. I mean, it's math instruction related. So the answer is we're going to tailor our small group instruction. I'm going to have my kids working on in centers, and I'm going to have my small group of kids working with me, but I'm going to group, these 4 kids together because they all struggled with addition with regrouping. But I'm going to group these 4 kids together because they struggled with addition across a 0. And I'm going to group these kids together because they just didn't understand addition at all. And I need to go all the way back. So that is absolutely the right answer. But let's take a look at A, B, and C without all of this nonsense, like without all of this and without all of this, and see why these are not the correct answer. Because if we cross off all of the withouts and we just look at the activity, we can reason through this as well. Providing all students with the same supplementary worksheet. That violates or that negates differentiated instruction. If I'm giving all students the same thing, then I'm not differentiating. B, assigning additional homework to students who scored below the class average. Well, if I'm assigning additional homework, I can't monitor to make sure the students are doing it correctly. I can't monitor to make sure the students are grasping that concept. I can't monitor to ensure that the parent isn't doing it for them. I can't monitor for their misconceptions. So assigning that additional homework really isn't going to guide instructional decisions and differentiate instruction. And continuing with the planned lesson, that is not using math data. I mean, step 1 is already negated. So that's really what we're looking at when we're looking at solving these kinds of problems. I'm going to catch up with my comments and then we'll move on to problem number 8, which is really problem number 2. Lisa. Hi, Lisa. It is good to see you. You came through as Facebook user when you were telling me that you were in Alabama, transferring to Florida and all of that. And so I'm happy to put a name to a face. Hey, Chris, good to see you. Always good to see familiar faces. You. Hey, Tammy, good to see you too. Houston, Texas, math 4 through 8. Field day kickball. Yeah, kickball's a good one. Tammy, prepping for 4 through 8 math as well. The 3-legged race. More help with functions and graphs and probability. All right. Functions. Let's add that to our list. So identifying if it is a function, graphing the function, looking for transformations in the function, all of the above. What are you looking for? And probability. I feel like probability lands on this list every single week. Probability. Awesome. And this is for 4th through 8th grade math. Awesome. All righty. Let's go ahead and move on. And you know what, Tammy? It's so funny. You said the three-legged race, and I forgot that I asked what the favorite field day activity was. And I was like, why did she write three-legged race? And then I was like, oh, functions, graphs, and probabilities. She probably is doing like a trifecta. And then I realized I asked what your favorite field day thing was. So that's how tired I am today. Let's go ahead and move on to the next problem. We're going to stick with some pedagogy problems, and then we'll go back to solving problems. Problem number 8. Which of the following best exemplifies the effective selection and analysis of instructional methods and tools, considering cognitive complexity and student needs for both small and large groups? Whoo! All right. Again, just so wordy. Like, that's all it is so wordy. Sorry, I was getting a sip of my drink. I always need like water or like juice because I talk and I don't talk quietly. And so it burns my throat. Does a Florida teaching certification work in Texas without having to take more tests? I do not know the answer to that question. You would have to contact like your state Department of Education and look for reciprocity rules, because some states have reciprocity and some don't. And so reciprocity is just the idea that a state will take another state's certification and say, yep, this is golden, this is good to go, and some states will not. And so you just have to look at your state reciprocity rules to see. You can also Google it, I think, to see. But you would want to talk to your state Department of Education to figure that out. All right, and good luck getting a hold of them. Which of the following best? Oh, these questions drive me nuts when they ask the best answer. Well, what if there's more than one correct answer? You know what? It's probably going to happen. And so when they say the best answer, they're probably hinting to you that there are multiple options that are halfway decent. Exemplifies the effective selection and analysis of instructional methods and tools. So I'm looking for the best way to like select instructional methods and tools, all while considering cognitive complexity and student needs for both small and large groups. So many pieces and parts. Using the traditional lecture format for all lessons. That word all is 99% of the time going to cue you in as probably not right, because what we do is not going to happen all the time. There are going to be times where I'm not going to use that and it's not going to be best. And using the traditional lecture format is not going to address student needs for both small and large groups. If I'm lecturing, I'm not even using small groups, so that wouldn't work. Integrating interactive whiteboards and computers in lessons. Interactive whiteboards could be a good instructional method, and computers in lessons, that could be an option. So let's keep going, because when we're looking at options, we know that there could be good options, but we're looking for the best for this. Adapting instructional strategies such as cooperative learning or peer tutoring for small groups based on the task complexity and individual student needs. Or employing technology demonstration purposes. Yeah, that's out. Like, employing technology for demonstration purposes? No. So is it going to be integrating interactive whiteboards or adapting instructional strategies? So that word adapting here really catches my eye, because if we're adapting our instructional strategies, we're really considering the student need by adapting it, and by broadening it to instructional strategies, we are looking at adapting those strategies. And then they gave us some examples based on student need. Student need. Ding, 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 ding. There's our answer. While this is an okay answer, and it's actually a good instructional strategy. It's not the best answer in this case, and that's what gets confusing. Let's go ahead and move on to problem number 9. We're going to skip problem number 9. All righty. And my computer, my iPad just decided to kaput on me. All right. So now that we have gone through those 2 problems, let's go ahead and look at problems that we can solve, right? So last week, if you were with us last week, there was 2 problems that we did that I said, you know what, we're just going to table that and come back to that next week due to the answers not being there. And I was like confused because I thought I knew what we were doing. And then I got confused because the answer wasn't there, but I was like, I know what I'm doing. So let's go back to those 2 problems and solve them. I solved it today on my own time so I could figure out where we went wrong, and I am ready to go. So this one was kind of cumbersome, but it's a good one. The population of a city is modeled by the exponential function P of t equals P times e to the kt power, where P is the initial population, T is the time in years, and K is a constant representing the growth rate. If the initial population of the city is 100,000 and the population doubles every 10 years, which of the following equations correctly represents the population of the city after T years? Okay, so this looks like that classic PE to the RT power, except in this case, it's PE to the KT power. K and R can be considered the same thing in this situation, where P is your initial population, T is the time of years, and K is a constant representing the growth rate, okay? Melody, this is not going to be on K6. GK, I don't know. I'm going to put a little GK question mark up here. I don't know off the top of my head. I don't think this is on the GKT. But if you're back next week, I will remember to just be like, yo, Melody, it's not on the GK. Or find me on Facebook and I can research it for you and just message you back. But it's definitely not on K6. Moving on. But remember, there's always, like when we're solving problems that are not within our content area, I always try to relate something in that problem for you so that it's not a waste of your time. So if the initial population of the city is 100,000, the population doubles every 10 years, which of the following correctly represents the population? Now, take the fact that my K through 6 people don't have to do this. Here's a good test taking strategy. First thing I'm going to do is I'm going to look, and this is for everybody, I'm going to look at my answer choices and see. They all kind of look the same. So I'm going to find the one thing that's different, or the 2 things that are different, or the 3 things that are different, so that I know what I'm looking for. So which of the following correctly represents the population? They all start with 100,000 at the beginning. If they didn't, that would be the first thing I would look for to eliminate answer choices. Because remember, our P is the initial amount. Our E is not any, it's a number. Like E is a literal number. And I know that that's confusing, but when you type in E into the calculator to the first power, it's a legit number. This is why I have a drink with me at all times. R, or K, is the growth rate. And T is the time. And if you are new with us, welcome to Math Night, where the iPad just disconnects on its own. And nobody told it to. Everybody wants the iPad to stay connected. But the iPad just said, you know what? Halfway through, I'm just going to disconnect. It's what it does every single week. So here we go. Here we go. Here we go. Here we go. Okay. So, NT is time. So what do we not have? I have my initial amount. A equals 100,000. Or P of T equals 100,000. E to the R. Do I have R? I don't have the rate. It says that it doubles every 10 years, but that's every 10 years. What's the rate every year? We don't know. But I have a time, but I want the constant, not the time. So really, what am I going to do to figure out what that growth rate is every year? Now, going back to the answer choices, if one of these answer choices didn't say 100,000 and it said something else like 50,000 or 200,000, you would be able to cross that off because the initial amount is 100,000. And so that would be a good test taking strategy, is if one of them didn't have that, it would be your go-to. But now what am I going to do to figure out K? Well, somehow I'm going to use that time of 10. So I'm going to have 100,000 E R. We don't know what the growth rate is, but we know that the time is 10. Well, after 10 years, it doubles. Every 10 years, it doubles. So if I've plugged 10 into my equation, how much do I have in my city after 10 years if my initial amount was 100,000? 200,000. It doubles every 10 years. Now I can solve for R. Divide both sides by 100,000. So E to the R times 10 power equals 2. How do I undo E? High school people, even 4 through 8 people. How do I undo E? Natural log both sides. So the natural log of 2 equals R times 10. Divide both sides by 10. So the natural log of 2 divided by 10 equals R. Plug it back in. So P of T equals 100,000 E to the R T. I notice in my answer choices, they all have a T as the variable. Now I'm just going to use my calculator to do ln of 2 divided by 10. I have to flip my iPhone calculator so I can access it. So 100,000 E to the 0.0693 times T. R equals 0.0693. So D is the correct answer. Questions, comments, concerns, things you want to see next week? I'm not done, but just figured I'd ask. All right, let's go ahead and move on to the next problem, and then we'll keep going. Problem number B. This was the other problem from last week that we needed to solve together. So let's read it. A password consists of 5 characters, where each character must be a digit 0 through 9 or a letter A through Z with no repetition allowed. How many different passwords can be formed? Now, elementary people, you don't need to know this either. But elementary people, you would need to know something like this. Alex is getting dressed. He has 4 pants, 2 shirts, and 3 pairs of shoes to choose from. How many outfits can he choose? And if you're anything like me, this is what you would have done. Pants, 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 shirt, shirt, shoe, shoe, shoe. If you're anything like me, this is what you did. And you went, this pant can go with this shirt or this shirt. This pant can go with this shirt or this shirt. This pant can go with this shirt or this shirt. And you drew a diagram. And then you said, this pant with this shirt can go with these 3 shoes. This pant with this shirt can go with these 3 shoes. This pant with this shirt can go with these 3 shoes. And that's how you solved the problem. And that's totally fine for you to solve the problem like that. While this may not be the problem you're solving, and this is, the process is the same. So I want you to pay attention to the process because, yes, you won't be dealing with numbers as big, but you will be dealing with problems like this. So let's take a look at it. A password consists of 5 characters where each character must be a digit or a letter. So I have 5 characters. 1, 2, 3, 4, 5. And it has to be a digit 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 options. Or a letter. How many letters do we have? If you don't know that and you're taking a test with probability, I would highly recommend you know how many letters are in the alphabet, how many cards are in a standard deck of cards, and how many sides are on a dice. Those are the 3 main things that they will ask. We have 26 letters in our alphabet. So how many possible options can sit in that first space? 36 options. But the key here is there is no repetition allowed, which means if I put the number 4 here, I cannot put a 4 anywhere else. So now instead of 10 digits, I have 9 digits remaining plus 26 equals 35. And now I choose the letter B. And so now instead of 26 letters, I have 25 letter choices, and I'm down to 34 options for this spot. Now, you could have chosen another number. You could have chosen another letter. It doesn't matter. What I want you to see is the pattern. I have 36 options, then I have 35 options, then I have 34 options, then I have how many options for this one? 33 options, and then I have how many options for this one? 32 options, and so I'm going to multiply all of those together. 36 times 35 times 34 times 33 times 32 equals 45,239. 45,239,040 options. It's a lot of passwords. Now, let's go back to the Alex question. He has 4 pants, 2 shirts, 3 shoes. How many outfit options does he have? 24. You're going to multiply those numbers together, and now no longer do you have to draw the pants and the shirts and the shoes and figure it all out. There's your cheat for today. All right, questions about that? Let's go ahead and keep rolling. Ooh, this is a good one. This is a really good one. All right, somebody asked for word problems. Here is your massive word problem. Emma is planning a road trip from city A to city B. She starts her journey at 8 a.m. and drives an average speed of 60 miles per hour. After driving for 2 hours, she takes a 30-minute break to stretch her legs, grab a snack. Then she continues driving at the same speed until she reaches City B 2 hours later. Emma realizes she forgot her phone charger and decides to turn back to City A to retrieve it. She drives back at an average speed of 50 miles per hour. Upon reaching City A, she spends 20 minutes picking up her charger and starts her journey back to City B. If Emma wants to arrive in City B by 5 p.m., which of the following statements is true? Y'all, listen. This problem has 6 lines of words. And you're thinking to yourself, Amy, I am taking a math test. I am not taking a comprehension test. What is this ridiculousness? And I'm going to say to you, you're right. We have no control over that. So let's go ahead and read this problem, because when I show you how easy this problem is, you're going to be like, wow, that was ridiculous. So she's planning a road trip. She starts at 8 a.m. She drives an average of 60 miles an hour. Did anybody ask in this problem anything about speed, miles, how far she traveled? No. When I look at the answer choices, I see Emma will arrive by 5. Emma will arrive after 5. Emma will never make it to City B, or Emma will make it to City B, but her arrival time cannot be determined. We can get rid of letter C. There is nothing in here that says she won't make it. There's no car accidents. There's no trees in the middle of the road. She doesn't run out of gas. Like, there's nothing in here about that. So we have to assume that she's going to arrive in City B because she's already on her journey. Can we determine the arrival time? Yes. So that's not correct either. So let's go ahead and start. 8 a.m. and she drives 60 miles an hour. The first time I read it, now there's this thing called the 3 reads protocol, and we have plenty of time to do it when we're in the classroom. We do not have time to do it when we're taking a test. I will typically read a problem like this at least 2 times just because I want to make sure I got it right. But if I see this many words, I'm probably going to skip it on a math test. However, if the entire math test has this many words, I'm also not going to skip every problem and give up. This problem is an easy problem. Let me show you. 8 o'clock. She drives for 2 hours. She takes a 30-minute break. So 8 o'clock, 9 o'clock, 10 o'clock, and she takes a 30-minute break, 10:30. So she drives, she takes a break. Then she continues driving until she reaches City B 2 hours later. We don't even have to worry about the speed or the miles. 10:30, 11:30, 12:30. She arrives in City B. Then she realizes she forgot her phone charger and turns around. She drives at an average speed of 50 miles per hour. Now, this is where miles per hour comes in handy. Could I sit here and figure out how many miles she drove in the morning? Yes. And then could I figure out how many miles she's going to drive in the afternoon, because it doesn't tell us how far she went or how long it took her? I could. But let's consider this. She got to City B at 12:30, and then she's going to turn around back to City A, and then turn around again and go back to City B, and she wants to be there by 5 o'clock? It took her 4.5 hours just to get there. So City A, so let's do this. 8 o'clock. She drives and drives and drives and drives and drives, and she starts in City A. And then she gets to City B at 12:30. That wasn't hard math. And then she turns around and goes back to City A. And then she has to go back to City B. She has to pick up her phone charger in City A and go back to City B. And she wants to be in City B by 5 o'clock. How long did it take her to do one section at 60 miles an hour? 4.5. Take out the 30-minute break, 4 hours. So if she's driving slower, it's going to take her more than 4 hours. But let's just estimate, because this is when estimating comes in handy. Let's just estimate it takes her 4 hours. She's not even going to get to City A until 4:30 or after. And then she has to go back to City B, and she wants to be there by 5 o'clock. It ain't going to happen. It just ain't going to happen. She will arrive. We can figure that out. Did it ask us to figure it out? No. But she'll arrive after 5 o'clock. She's not going to make it by 5 o'clock. Interesting, huh? So they gave us a whole bunch of information that doesn't matter. We did not need to know she traveled 60 miles an hour. We did not need to know she traveled 50 miles an hour. It was extraneous because we were able to figure it out without doing a whole bunch more math. Now, if we wanted to know the exact time, or this timeline was way more narrow and tight, and I actually needed to solve it, that 60 and that 50 are necessary pieces. But with the estimation piece here, she's not going to make it to City B until like 8:30 or 9 something. So we didn't need to solve that because it's so unreasonable. Does that make sense? All right, let's go ahead and look at this same problem with different answer choices, where this is going to be critical. Emma is planning the same exact trip. All of this is exactly the same. But now the answer choices are a little different. Which of the following statements is true? And actually, I should have just said, I kept the question the same, but like that, she's not going to arrive in City B by 5 o'clock. So really, we should just say which of the following statements is true, right? So let's go ahead and explore this. Either Emma arrives to City B for the first time at 12:30 and arrives at City A after turning around at 5:30. Emma arrives to City B the first time at 12:30 and arrives to City A after turning around at 5:38. Emma arrives to City B the first time at 12 and then arrives at City A after turning around at 5:30. Or City B at 12, turning around at 5:30. So when I look at these again, when I'm looking at answer choices, I'm looking for consistencies and differences. If everything is different about them, fine, whatever. But if there are consistencies, it can help me kind of figure it out. So let's look for consistencies. It's either she arrives to City B at 12:30 or she arrives to City B at 12. Those are my only two options. And then she either turns around at 5:30 or she turns around at 5:38. Those are my only two options. So she either turns around at 5:30 or she turns around at 5:38. That should have an 8. That's my fault. So how am I going to figure this out? Well, the first part is the most simple part. She starts her journey at 8 and drives an average speed of 60 miles an hour. But this first leg, they give us all of the times, so we don't need to know that. She drives for 2 hours. So what time does she get to her break spot? 10 o'clock. And then she has a 30-minute break. That brings us to 10:30. And then she reaches City B 2 hours later. So we add 2 more hours to that and we get 12:30. So she arrives to City B at 12:30. C and D are out. If that's as far as you can get, at least you can have a 50-50 shot. Don't be discouraged when you get this far and then you're like, I don't know what to do now. You got this far. Like, that's huge. Now, this is where those speeds come into play. So how are we going to figure out when she arrives to City A and turns around? Now we have to figure out how many miles she traveled in the morning to figure out how long it takes her to get to turn around. So if she drives 60 miles an hour, I know she drove 120 miles in the morning before the break and 120 miles after the break, which equals 240 total miles from City A to City B. Now, you and I both know road trips aren't like that. I don't get in the car, push a button, and it goes 60 miles an hour, and then I stay at 60 miles an hour the entire time. It just doesn't work like that. But in story problem world, it does. So in this world, that's how we're traveling. Then I know that she traveled 240 miles. So now I know she has to travel 240 miles to get back to go get her phone charger. I don't know who's turning around for 240 miles to go get a phone charger, but this girl is. Emma is. So let's just be mind blown by that. So 240 miles. But when she turns around, she's not driving at the same speed. Now she's driving 50 miles an hour instead of 60 miles an hour. So I need to take my miles and divide it by the the speed, and that will give me the time. So distance equals rate times time. But if I do distance divided by rate, I can get the time. So 240 divided by 50. Let's take a look at that. $240 divided by 50, 4.8. So what does that mean? That means it took her 4.8 hours to get from City B back to City A. So she got to City A at 12:30, but she didn't do anything in City A. She didn't grab lunch. She didn't stop and get gas. She got there and she turned around and went right back. So now I am going to figure out what time she gets to City A after she turned around at 12:30. And that's what these are talking about. So 12:30 plus 4 hours, 12:30, 1:32, 33, 34, 30. And then I need to figure out what 0.8 hours is in minutes. Now, elementary people, this is for you. In fact, this whole word problem could be for you. This could be for anybody. So I need to know how many minutes is 0.8. I'm going to do 60 times 0.8, and that will tell me how many minutes the 0.8 represents. And that's going to equal 48 minutes. So 4.8 hours is 4 hours and 48 minutes. So 4:30 plus 48 minutes. I don't even need to solve that. This is what I want you to get out of this. Stop doing extra math when we don't need to. I have 2 answers left. I have 5:30 or I have 5:38. I'm taking a 0 and adding an 8 to it. It's not going to equal 530. It's going to have to be 538. Don't do extra math when you're already running out of time. Don't do extra math and subject yourself to a possible computation error that we all make. If you've been with me for long enough, you've watched me make computation errors because I'm human just like you. So I don't need to solve that. 430 plus an extra 48 minutes is going to be not 538 though. 538 would be 68 minutes. So that's a typo on my end. Here I am telling you, don't do the extra. She arrives at City A at 5:18. So it's either 5:10 or 5:18. And then she turns around at 5:38 because she spends 20 minutes picking up that charger. It's just, I didn't word this very well. That's all. So she arrives to City A at 5:18 and then turns back around. Goodness, that's a long day of driving at 5:38 because she takes 20 minutes to pick up that charger. So the answer is still B, 5:18. Questions? That was a fun one. All right, we have time for one more. I'm going to do one that's just for my elementary people, and then I'm going to turn it back over to Dr. A. Amelia is making blankets. She can make 8 blankets with 32 yards of material. How many yards of material would it be required to make 22 blankets? So here's what I want you to think about. This is a ratio problem, so ratios and proportions. But there's also a little bit of common sense that goes into it. She can make 8 blankets with 32 yards of material. So if I have 8 blankets, 3, 4, 5, 6, 7, 8. And now I want to make how much? I want to make 22 blankets. Am I making more blankets or less blankets? I'm making more blankets, which means I'm going to need more material than 32 yards. So 6 and 12 are automatically out. I can't make 22 blankets with 6 yards of material when it took me 32 yards of material to make 8 blankets. Does that make sense? So, how many yards would we need? Well, I can do this 2 ways. How many yards do I need for 1 blanket? 32 divided by 8 equals 4. So I need 4 yards for this blanket and 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 this one and this one and this one. How many yards do I need for 22 blankets? 88. Done. For those of you who love ratios and proportions, you can also set it up like this. Blankets over yards equals blankets over yards. You gotta make sure your ratios match though. So 8 blankets and 32 yards equals 22 blankets and X yards. The number one mistake people are gonna make is they're gonna do this. And that's not correct. And that will get you the wrong answer for sure. So cross multiply. 32 times 22. 704 equals 8x. Divide both sides by 8. X equals 88. Questions? I'm going to go back to my next week's slide. I'm going to turn it over to Dr. A. You let me know what you want to see in the comment box, and I will see you guys next week. Thanks for being such a great audience, and I hope that you have a great rest of your week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.